Hi everyone, today we're going to talk about discrete and continuous domains, and we're going to talk about how to write different types of domains. So there are two types of domains. There's discrete and continuous. So a discrete domain is like the type we've been working with. It's where you just have specific, only certain values within an interval, and it usually looks like this, where there's just a bunch of specific coordinates on a number line. So if I were to describe this domain like we've done before, you literally just list out the numbers. You would say 1, 2, 3, 4, and 5. So notice that it's just these exact points. It's nothing in between them. Now a continuous domain looks more like a solid line. So a domain might include all of the little numbers in between. So it might include 1, 2, 3, 4, and 5, but it might also include all of the fractions and decimals in between. So when you have a line or a solid interval, we call that a continuous domain. So this is what we're going to focus on today, because the way you describe that is a little bit different, because there's no way for us to possibly name every single number in here, because there's actually all these tiny little decimals in between. So there has to be a better way for us to name this interval. So there are two ways that we're going to practice writing these types of domains. We're going to use inequality notation, and we're going to use interval notation. So we're going to practice both. So essentially, if you think of that last example, we'll start just by looking at number lines. So if you have a closed circle on either end, it means that that point is included, and so we're going to use less than or equal to, or greater than or equal to. We're going to include the equal to, because closed circle means that that number is included. Now, if you see an open circle, we're just going to use less than or greater than, because that number is actually not included as part of our answer. And if we have a situation where we have an arrow just pointing to the right, so the numbers go up forever or they go down forever, we're actually going to use the symbol infinity to describe that. So infinity is the concept of if we went up forever and ever, or if we went down forever and ever. Because there's no real number there, we call it infinity, and this is the symbol for infinity. Now, interval notation, it's the same idea. There's a way to show if a number is included or not. So closed circle, the number is included, and we use these brackets. And an open circle, the number is not included, so we use these parentheses. So if the number is included, we use a bracket, and if the number is not included, we use a parenthesis. Okay, so let's start by looking at these first two examples. So here we have a number line. We'll say these are our x values, and you can see that the interval that we're trying to describe is everything 2 and bigger. So instead of having to list out 2 and 3 and 4 and 5 and everything until positive infinity, we can use two different ways, inequalities or intervals, to do that. So let's start with the inequality notation, which is over here. So I can see that it's all of the x values that are 2 and bigger. So we'll say when x is greater than or equal to 2. That describes all of these numbers. And notice, since it's a closed circle, we do greater than or equal to. Now, if you're using interval notation, this one's a little bit, I think it's easier to use interval notation. We look at the number on the far left, and then we look at the number on the far right. So if you look at the number on the left, the smallest possible number that our interval includes is 2. And since it includes the number 2, we're going to use a bracket, and then we put a 2. And now we put a comma, and then we look at what's the biggest number that's possibly included. Now, since we see an arrow here, this implies that we're going to continue on forever and ever and ever, which we call infinity. So our biggest number here is infinity. And with infinity, we always use a parenthesis because infinity is not really a number, so we can't really include it. So it's always a parenthesis with infinity. So you can either say all x values greater than or equal to 2, or all the numbers from 2 to infinity and including 2. Now let's try this other one. You can see that this number line represents all of the x values that are smaller than 8 and not including 8. So that means that we can say x is less than 8. So once again, you can see that the numbers that are included are all of the numbers that are smaller than 8, but not including 8 because it is an open circle. Now, if we're doing interval notation, we're always going to start at the left with the smallest possible number. So since this graph is just facing to the left with an arrow, it means it's going to keep going down forever and ever and ever, which we call negative infinity. So remember, we never include that as part of our interval, so we use a parenthesis and then negative infinity. And then here we look for our biggest possible number. So we go all the way up until we reach 8. So 8 is our upper bound. And since we have this open circle here, 8 is not included, so we do a parenthesis again. So these two things mean the same. That x is less than 8 means all the numbers smaller than 8, and between negative infinity and 8 means the same exact thing. All right, see if you can pause the video and give these two examples a try. Okay, so if you look here, this first example, we can see that we want to try to describe all of the numbers that are smaller than 4. So we can just say x is less than 4. That's how we can describe that with an inequality. And it's an open circle, so we just say less than. Or we can use interval notation, and we can say, well, our lowest possible number is negative infinity because it's going down forever. And our highest possible number is 4. Neither of those are included, so we use parentheses. Now for part B, you can see that we're trying to describe all of the numbers 6 and above. So we can say x is greater than or equal to 6 because we have a closed circle. Or we can use interval, and we can describe our leftmost point as 6, bracket because it's included. And since it's going up forever, our rightmost point is infinity with a parenthesis. All right, so now we're going to try to describe different domain intervals where they have a stopping and an end point. So notice that it's no longer going up to infinity or down to negative infinity. So let's look at this first one. I can see that my numbers are everything between 3 and 8. So using interval notation, this is actually really easy. We do a bracket because it's a closed circle. Our smallest point is 3, and our largest point is 8, and then we do another closed circle, so another bracket. Using an inequality, it's also not too bad. When you have something like this, you're actually going to start by setting up the outside numbers. So I see that our smallest number is 3, and then leave a space, and then our biggest number is 8. Now, x is all of the numbers in between and including, and since these are both closed circles, we're going to do less than or equal to and less than or equal to. So when you're trying to describe numbers in between 2 points, we're always going to set it up like this. We're going to do the number that's smaller than x and the number that's bigger than x, and these should always be facing the same way. The only thing that might change is you might not include the line underneath, depending on if it's open or closed. So if you look at the second example, you'll see that we do have the closed circles. So if we're doing interval notation, we'll use a parenthesis because it's open. Our smallest number is 2, and our biggest number is 5, and that's also an open circle, so we do another parenthesis. Now for the inequality, we can set it up like this. 2 is the smallest, 5 is the biggest, and x is everything in between. And since it's not including those numbers, we don't include the line underneath. So it just looks like this. So you can see that x is literally squished in between these two numbers, just like this line is squished in between those two numbers. For this last example, let's do interval notation first. So we start with a bracket because we have a closed circle. 3 is our smallest number, 10 is our biggest number, and we put a parenthesis here because it's an open circle. And then if we did inequalities, we do the lowest is 3, the highest is 10, x is in the middle. Now, since this is a closed circle, we do less than or equal to, and since this is an open circle, we do less than and no or equal to. So it just looks like this. Now, if I read this, you can kind of read it backwards, like x is greater than or equal to 3, and then x is less than 10. So it's everything in between, including 3, but not including 10. Okay, go ahead and pause this video and give this last one a try. This was supposed to be a you try. Okay, go ahead and check your answers. So here it's between 4 and 6, it's closed dots, so both are brackets. And then it's between 4 and 6, and because it's closed dots, we include the or equal to sign in our answer. For part B, it's from 1 to 10, but it's an open circle, so we do parentheses. And then here you can see the 1 and the 10, and since they're open circles, we just say less than and not less than or equal to. And last, we have from 6 to 7. 6 has open circle, so it's a parenthesis. 7 has a closed circle, so it's a bracket. And here you can see that for this first symbol, there's no or equal to, and for the second one there is, because this is open and this is closed. All right, that is all for today's lesson. Thank you so much for watching.